Now, we have another question, still on complex number. Sorry, Cauchy Riemann, yeah, a complex number. Sure. You see that this one now, f of z is equals to bar z, and as you know, bar z is the conjugate of z itself. So instead of having s plus iy, we'll be having s minus iy. You get? We now see that the only real part here is x. That's our u. The only what's the name now? The only imaginary part here is y. Yes, sorry, minus y, because of the minus here. It's minus y. You get? So that's what happened there. Remember that bar z is s minus iy, and that minus must be on the imaginary side of it. Take notes. So you have to find your us, your uy as usual. If you differentiate s with respect to x, you have 1. 1 is at the top of the place. When 1 go to the back, go to the front, you have 1 times s. You move 1 from that power. 1 minus 1 is 0. S is power 0 is still 1. That's what you have here. If you differentiate with respect to y, it doesn't make sense because there's no y there. So automatically this thing is as good as 0 because there's no y there to differentiate it with. Just like when you're differentiating the constant gives you what? 0. That's what happened there. Differentiating y with respect, sorry, minus y with respect to s. Also, there's no x here, but we're dealing with respect to x. This one will give you 0. When I differentiate it with respect to y now, y will give me 1. The minus there is minus 1. Now, when we check whether us is equals to uy and vy, sorry, as usual. us and vy are not equal. No, they're not equal. It's false. You see, false. Checking again whether uy is equals to vx. That's the negative. Of course, 0 is equals to minus 0. That's correct. But then the first one failed. First condition failed. The first condition said us equals to vy, but it failed. The second one said vy equals to ui equals to vs minus vs, and it's correct, but the first one failed, so it's not. And because it is not Cauchy Riemann, it means that it's not also what? Analytic. In this particular case, there is no complex derivative at any point. So I mentioned earlier, I don't even need this grammar speaking.